Hello and welcome back. Now before we start diving into the additional data preparation steps which you want to do, I just want to inform you that there's something else you can do. So under File here, of course, you also have the option to create, either rename the notebook and also save the notebook. For instance, in your Drive account, right? If you want to do that, or also save it on GitHub, or also download the IPython. As you can see here, it's an IPython notebook. You can download it or download as a PY file. That's also possible. Okay, just wanted to mention that. So also click on save here. I click on save, even though Colab saves that a few seconds or every few seconds, I think, but this is just something I wanted to mention here. Okay, that's it, and let's dive into the data preparation. So go on code here, and then we start diving into preparing our data. Of course, you can also go on here, and then say now data prep. Okay, data prep, or write a few additional information for each of the steps if you want to do that. That's also best practice. Okay, so for the data preparation itself, what I want to do is I want to at first convert those images to NumPy arrays, and from those arrays I only want to have one color channel. I said it before, we want to train our network not on the 3 color channels but on just on 1 color channel. So that is why I simply use in this case this additional data preparation step. So let's say train images like that, and then it says equal to np.array, right? So convert it to NumPy arrays, and now we simply specify here for let's say I'm using here a list comprehension. So I say example, and now I affirm it to the image itself. So image, and now I say in this case .numpy. So .numpy allows basically to convert a tensor back to a NumPy array. Okay, that's what we want to do. So .numpy here, and then I specify I want to have all the rows, all the columns from the image, but only in this case that's comma 0. 0 simply means only one of the color channels. Okay, in this case it's the first one, but you could also use the second and third one probably, but simply refer to 0 in this case here. Okay, so that's what you want to do. Basically, we create here a list comprehension. This list comprehension with this example image .numpy. .numpy is the command if you want to convert a tensor back into a NumPy array. Then because it's a list comprehension, it creates a list, and because we want to convert this list back into a NumPy array, that is why we cover it with the NP array out there. Okay, so we got this, and then what I want to do here is, of course, the list comprehension is not done, so I simply say for, in this case, example in dstring. Okay, dstring. So that's basically what I do here, and we'll do the same for the labels as well as for in this case, the test images as well as the test labels, right? So all of them. Okay, so that's what we do. So train images NP array example image.numpy, all the rows, all the columns, but only in this case the first color channel, for example in dstring. So that's a list comprehension, converting the tensors back into NumPy arrays and only keep one color channel, and then we want to convert this back into NumPy array. That's what happens here. Okay, so we got this, and we do the same for the labels. So go in here and say that the train labels. And just by the way, if you're wondering, this example is simply a name, in this case example, for example in dstring. So basically, if you want to rename this again to banana, then of course you can also go for banana in dstring. Basically, we loop through the dstring. We defined the dstring up there, here, dstring. So that's name, of course, is fixed because we have it up here. But what you use, for example, doesn't matter. But we want to have the images here, okay? And why the images? Why it's called images? If you go back to the dataset, and that is why, again, it's really helpful to print this information, because here it's called test and train, and the feature names here, the dictionary is referring to image and label. Okay, so that is why I'm referring here down there to image, and then of course if we do the same for the labels, we refer to a label. Okay, so then we say simple is equal to np.array, and p.array here again we're using a list comprehension, and I'm referring to the example or the banana if you want to call it banana, and then referring to a label, in this case label .numpy, so convert it into a NumPy array, each of those tensors, and then for example, of course you need to spell it correctly, example in this case in dstring, okay, like that. And because here is just a label, we don't have to specify the color channels here. So that is why we have this here, and actually this one here, right, refers to the complete image, so the image width and the image height, as well as one of the color channels. Of course, this is not necessary for the label, because the label is simply a label, it's not an image. Okay, so we got this as well. And then we do it the same for the test. So let's say test images, in this case, images is equal to np.array, like that. Again, we're using a list comprehension, and referring to, in this case, example, and then the image itself, image.numpy, so also convert it into a NumPy array, the tensor into a NumPy array, and then we simply say here, the same is true here, all the rows, all the columns, but please only the first color channel in our case, so we got this as well, and then say for example in this case ds test. So we got this as well, and then of course the last one here, say the test labels like that is equal to, again, it's an array, we want to convert it into an array, so np.array here, and then again we create here the list comprehension, example, in this case label like that, .numpy, and then we do not need to specify color channels here because it's only labels, so it's only text, and then say for example, you spell it correctly, for example in this case ds test. Okay, so that's what we do, and hopefully I explained it, but just in case you didn't get it, let me just talk about it one more time. So basically we do the same for the training and the testing. We use a list comprehension in this case. We simply say example, could be a banana as well, doesn't matter, but basically we are referring to the image. The image itself, it's called image because the dictionary here in this data set is called image here. Okay, it's the image and label. As you can see here, the feature dics, that's where we need to refer to image and label as names. And what we want to do is we want to use each of those images in the training data set. We convert this tensor, what basically at the beginning it's a tensor. We want to convert it back into a NumPy array. That's why we call it .numpy. Then we say we only want to keep one of the color channels. And then we simply say we want to do this for each of the image in the training data set. Okay? And of course, because we use a list comprehension here, what we get as an output is a list. But what we want is an array. That is why we use the np.array function here to convert this list back into a NumPy array. And the same is true for the labels, of course, but there we don't have any color channels. That is why we can simply say .numpy and don't need this, all the rows, all the columns, and only one color channel, or basically the height and the width of the image and all the color channels. We only need to keep, in this case, basically the label itself. Okay, so that is that. So let's actually run this. Press Ctrl R to run this here, and just wait a second, and basically it's still running. Of course, I can create a new code cell during that and continue our data pre-processing. So what we want to do is we want to work with those train images and train labels. You can see now we are done with the run. And what we want to do is we want to now reshape it. So let's say the train images in this case is equal to train images dot reshape. Reshape command simply allows us to reshape the NumPy array. Okay, to put it in a new shape. And in this case, what we want to have is we want to have, let me actually scroll up there just a second if you can see it. Okay, here you can see the test dataset is in this case 372 images. The training dataset is 2,520 images. Okay, so that's why if I scroll down in here in the reshape, I can simply say, okay, I want to have those 2,520 datasets or images in our training dataset. I want to reshape them in 2,520. 300 by 300 because this is the image width and height, and then I want to expand one dimension. That is why I'm using this one here. Okay, so we can also, let me actually show it to you. If I go in here and I simply say train images, in this case dot shape, right? You can call the shape here and you can run this, and you'll see that that's basically the shape which we start with. Okay, we got 2,520 images, and all those images have a height and a width of 300 by 300, and that is also specified if we scroll up here, there, right? We got the images with a shape of 300, 300. At the beginning, we had 3 color channels, but what we did is we converted this here into 1 color channel. So there's only 1 color channel left. And then we simply have, in this case, 2,520 images by 300 by 300. Okay? So that's exactly what we have here. But what we want is we want to expand the dimensions. So we want to have 1 extra dimension at the end. So that is why we say train images.reshape, all those images by 300, 300. So we keep the size intact, but we add 1 additional dimension here, like that. Okay, and we do the same for test. So test images is equal to test images.reshape. Here we go. And again, we simply referring to, in this case, 372, which is the amount of test images we have, and the shape was 300, 300, but we simply add 1 additional dimension here, like that. Okay, so we got this as well. And then what we also want to do is we want to convert those images here now into different data types. So we want to make sure that we got float data types, because this is basically the data type which neural networks, in this case, at least from TensorFlow perspective, work best with. I'm not sure even if they work with different kinds of data types here, but we convert it to float just to make sure that this will work. Okay, so let's say train images is equal to, and I'll simply say train images, yeah, dot or s type. Here we go. And S type allows us to convert it to a specific data type, and we simply specify, in this case, float 32. Okay, so it's a float 32 data type, and we do the same for the test images. So test images is equal to test images, in this case, dot s type, and the same here, we convert it into float 32. Just make sure that we got the correct data type for our model. And then finally, what we want to do is we want to now normalize our data, because at the beginning we got images between 0 and 255, considering the color dimension of the image, and we want to normalize it because best practice and the neural networks best work with normalized data. Okay, so we want to normalize the data always. That's best practice, at least from my point of view and what my experience. Always it's best to normalize the data. When you train a neural network, just make sure that the training works better and you get a higher score at the end. So we want to make sure that we use train images after converting them into, or after reshaping them and after converting them into a float data type. We simply want to then say is images, and we want to is equal to train images, and divide this by 255. Okay, and do the same here for the test images. So say test images is equal to test images divided by 255. And because it's a NumPy array currently, that simply means or makes sure that each specific data point is divided by 255 in the image itself. Okay, so that's that. And let's actually run the cell. So press Control, in this case Control Enter to run it, or simply click the run button, and we are done. And that's all we do now here for the data processing. And just to make sure that we can see that what the data looks like, so train images dot shape, just to make sure that this additional dimension is available here for us, and we can see that the train images dot shape is 2520 by 300 by 300 pixels, and 1 in this case for the color channel here, right, which is not there here. Okay, so that worked, and that's it for the data preparation. And in the next video we start basically creating the network structure. Okay, so can't wait to see you there.